science O-level, we will be going through magnetism, and next week will be on electromagnetism. Okay. Alright, so today we'll just go through magnetism, and next week we'll go through electromagnetism. After that we'll switch back to chemistry. Yeah. So we will learn about the two different poles of magnetism, the test for magnetism. We will learn about the drawings. Then we will have to concentrate on this thing called the induced magnetism. There's this thing called electromagnetism, which will be covered next week. Then comparison between iron and steel. Alright, anyone don't know what is magnet? You all know what is magnet?
I know.
You all know?
But I didn't bring one.
Okay, so basically a typical magnet is maybe perhaps it's a bar magnet, and then there's horseshoes, there's a lot of different types. So normally we know that there is a pole. Alright, there is a pole. So this is the north pole and this is a south pole. So for example, if you bring another magnet, let's say that this is also a north and this is a south, and what would you experience?
Push each other.
Yeah, they push each other away. So there's a repulsion. Joshua, okay?
Yep.
Okay. So of course, if you put another magnet here, say this is north and this is south. So this part they will attract. So they will pull towards each other. So this is attraction. In this particular chapter, there is no formulas.
Yay.
Formulas will only be taught in A levels.
Yay.
So that is why we just need to understand the foundation. Okay. So for example, we are supposed to learn these four materials. I call them coins.
Coins.
Alright. So they stand for four different materials. Cobalt. I stand for iron. Then nickel and steel. Alright. These four materials, we call them a special name. We call them ferromagnetic material. Alright? Ferro actually comes from a word iron. Alright? In fact, if you were to look at in your periodic table, for iron, the symbol is not I, but rather F. Alright? Fe, right? So what does it stand for? Actually, it stands for ferrum. Alright? So when they say
for iron.
the original name for iron. So it's known as a ferromagnetic material because they can be made into magnet, permanent magnet, or temporary magnet. The first civilizations that found everything about magnetism are the Chinese. So they are the first one that created compass.
Really?
Yeah, really. So we can see that these are the four materials, but the focus, as you can see here, we only will be interested on iron and steel. But these four materials will be the same four material that you learn in primary school, PSLE, Sec 1, Sec 2, Sec 3, Sec 4 will always still be the same, even all the way to A levels. So they recognize that these are the four major ones. But of course, when you move on to university, if you are going, then you will explore other particular materials that also have magnetic properties. Was it okay? So, how do we test whether a particular substance, let's say that this pen, whether it is a magnet or not. For example, let's say that this is a pen. Alright, so you bring a magnet, alright, and then there is no repulsion, there is no attraction, so you can conclude that this is not magnet, correct? Why? Because no attraction or repulsion. Okay, but let's just say that now you bring another pen and then there is an attraction. You felt that the pen will move towards the magnet. Can you conclude that this is a magnet?
No.
No.
It's just
It's
a
only,
metal.
it could be just a magnetic material.
Very good. Not just a metal, magnetic material. So this is not conclusive, right? Not conclusive. Whether this pen is a magnet.
So you need to turn the magnet the other way to the south and to see whether it repels.
Very good. Alright. So since this is not conclusive, so Chester suggested that, okay, yes, reverse the magnet now. So now it becomes south and north. And then you check if it is repulsion, right? Correct? But let's just say that it's still attraction.
And it's not.
This is magnetic
And it's
material.
a magnetic material and not magnetic
Correct. So the pen is a
material.
ferromagnetic material. Magnetic materials, if you just see this magnetic material, it will be accepted in PSLE, but not O levels. So we say that the pen is a ferromagnetic material. If there is repulsion,
It is the magnet.
right, so the pen is a magnet. So what's the conclusion? So the conclusion is only when you can prove that a particular substance repel, then you can prove that it is a magnet. If it's not repelling, it is not conclusive. If you reverse it, still attract, you can confirm that it is just a ferromagnetic material. Was it okay? Okay, so now let's move on to drawings.
Who said that?
Josh.
Yeah, I can't.
Just wait to make it.
Okay,
Did you last year? Say you will.
so let's take a look at this part. Let's say this is the bar magnet. Under O level, we are needed, alright, to learn how to draw the magnetic field lines. Alright? So the minimum lines is 8 lines. Most schools, if you go, the teacher will want to see 8 lines. The problem with students is when we say lines, they think that of it's a straight line. But these lines are all curved. So it's all curved lines. So it's like that 1, 2, 3, 4, 5,
It's similar to
7.
butterfly. It's similar to Earth magnetic field, right?
Yeah, it is.
It looks like
yeah,
a ear.
correct.
But I think 2 ears. To me, Earth magnetic field look more like a spider than this.
So you have to draw an arrow, okay, and the physicist has agreed that the magnetic field, okay, the arrow is pointing away from the north and pointing towards the south. So this is the first drawing. What happens when you have, let's say, a north and the south facing each other? Alright, if this is parallel, these two lines are parallel, then the few lines will be parallel and equally spacing. So 1, 2, 3, 4, 5, 6, 7. At the end, you curve it a little bit, and you draw with a arrow. So that is the next drawing that you are supposed to learn.
Let me draw.
I know.
Alright? What happens if it is actually a north facing a north? Alright? This is what you're supposed to draw. So they will turn away from each other and they will not join together.
It's the same for south and south.
South and south, very good. Yes. So this point, we call it a point X. Point X is a neutral point. Alright, it's a point where no magnetic force experienced. So if you put another magnet in there, alright, there will be no repulsion, there will be no attraction. So just now Zachary mentioned something. What happens if it's a south-south? Then he is correct. That also will be exactly the same drawing. But this time round, the arrow is pointing towards the south.
It looks like the angry sign, that sign there.
What's that?
You know the cartoon always.
Oh, the angry sign. How to draw an angry sign? Then like that.
Yeah. Yeah, like that. Yeah, that's like that always.
Okay. Okay.
But you didn't draw the circle.
Done already?
Not yet.
Okay, there is a space here. I'll just draw it here.
Uncle David,
Hi.
so that means in O levels you must write ferromagnetic material.
Yeah. Because these are the only 4 materials that we learn. Okay. What happens if there is a north, south,
Line.
north, south? Alright? So this part, no effects. Alright? Alright, so for this part, it's the part where you are supposed to show that there is a repulsion. So arrow, 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 arrow. Make sure the arrow is correct. And you are supposed to, there is two neutral point, which is here and here. And the last drawings is when there is a north-south and south-north. So this part, there is a attraction, 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 attraction. So make sure that you draw the arrow carefully. So 1, 2, 3, 4, 5, 6. 6 drawings.
I only draw one.
Okay.
How is it?
No space area.
I'm sorry?
I thought that I can say that.
Yeah, because this north and south will attract. North and south
I
attract.
thought the one mine got cross. Is it correct or?
Cross means this one. It's an X.
It's the
Neutral point.
Oh, yes.
Yeah, same.
Wrong.
Then the face part.
Okay, done?
Yes.
Not yet.
Not yet. Wow, so that's all for the drawing.
I'm not yet.
You mean the drawing there?
Only do 2, 3. Wait, 2. I only draw one because I
Wait,
didn't
the
know.
NSSS and the NSSM haven't go.
Okay, just take your time.
So that means the north and south will stick together.
Oh, mine looks like it. Yeah, no, it won't like this stick. Well, it's feel very strong stick. What was
Like 2. Good chance. Oh, good. Okay.
What's the
Both try also.
what's the decision?
You are brothers.
Because we do together, ma.
So sure.
Can you put down a bit?
Oh, later.
Sorry, okay, I think
Oh yeah, then you had the homework last week.
Yeah, where's it? Okay, later pass it to me. Draw already?
Good try.
Yeah, I just want to. I think I took a picture, but it's okay.
Easy, I put
Let's
it
go
down.
with the picture.
Then correct.
Same, I also do same.
I will discuss one particular question on the 3-pin part one. Okay. So I've done with the polls, I've done with the test, I've done with the drawings. Now I need to move on to induced magnetism. Alright? Okay. Have you all tried, before I move on to induced magnetism, have you ever tried use a bar magnet, hang it, and then after that tie it to this bar magnet, and then let it hang on its own? Yeah?
I think you will drop.
No? I think I did say that. Because the rest of you all remember.
Yeah, I
Never mind,
think
you can try.
Teacher,
You should do that when you're lost in the
question.
No, we haven't done the question yet.
You
I'm
should,
still doing magnetism. After this, I will go through homework.
you should do this when you're lost in the forest.
Yes,
So
correct.
is it a drawing or
What's
what?
that compass?
There's no much forest in Singapore.
Is it a drawing or
I say
what?
if.
Huh?
Is it a drawing or a?
I was asking a question. You finished drawing already? No, you haven't finished drawing.
Yeah, same as me. I'm here. Okay, three drawings are up and
I finished all already. Hey, I also finished all because to the fast.
Haha. Best idea ever.
It's like a rope already.
You know one thing easy I do? Is it?
Oh, good.
Best idea.
Oh. So many.
Tell me where. Minimum 8 lines. Huh?
Minimum 10,000.
No.
If you want to draw more lines, it's good. But the minimum is.
But how to draw more lines? How to draw more lines?
How to draw one line?
I didn't know those things.
Okay, now I only got one. I only got two more to draw. I only got
I only
two
got
more
one.
to draw. No, wait. Yes, two more to draw. This is gonna take 10,000 years to finish.
Divide by 10,000.
Divided by 10,000. Then once they finish it around moving paradise.
After we got the
That'll take about 10 million years. That's a very long time. Dude, erase all these signs.
No more magnet spin.
How come they got 10 lines?
Yeah, minimum 8 lines. So some people they choose not to draw this one. They try not to draw this one, and this one. So it's 8 lines. Huh?
Wow, I just draw those two.
Oh man, extra marks.
There's nothing wrong with drawing more,
Extra
but
marks.
you will be penalized when you draw less.
Yeah.
What's spinner?
It means like you like
Lost marks.
0 marks.
Okay.
You consider the reason why we continue. And then we like put in a space. Put in a space.
Huh?
You know, I wish
Somebody draw us by the time he finished
outer space.
the
So it's pretty fun. You see, if luckily, right,
Yeah.
this one less thing so that I can move this thing here.
One of no return.
Yeah.
I love it. Exaggerate.
Wow, this one
Make sure when you draw,
black.
the line all connected. When drawing not so good. Make sure it really can touch. Touch.
It's a
Touch.
bit like
Touch.
a big central of the galaxy.
What?
The central of the
They say
galaxy.
it's a super massive.
They say
This one is like that cool.
might be.
Who else is drawing?
Everything near it, but then we are not near it. So 8 hours.
The hanging like that, else under is
Like yes,
like
sorry.
this.
No, it's still under just magnetism. I haven't reached introduce it. I'm just this is just a very common question. Like if you have a magnet, so those who have magnet at home, you can tie it. Alright, tie this, and then let it just rotate on its own, and slowly it will come to a stop. And when it comes to a stop, you will see that the north and the
There's
south.
5 drawings.
Alright.
There's
So,
6.
of course, this is actually pointing to where?
No.
The north pole of the earth, right?
Yeah.
And this one will
South.
point to the south pole, right?
Oh.
Has anyone actually wondering, is there something wrong with this?
Yeah. Because I think if the coils, then it keeps spinning, after the coils become very tight, then after it will come back again.
Okay, that's interesting. Anybody else that ever wonder that?
There is nothing that holding the string.
Okay, you can hold it. Yeah, hold it.
I'll add in a lock. I'll add in the somebody tie around the lock.
Okay.
But the lock nothing to support the lock. Okay, I'll draw a tree.
So you look at this planet Earth, right?
But nothing to support the tree.
So when you look at this planet Earth, this part is the north pole, and this is the south pole, correct?
Yeah, but magnetic north is not
Gigantic magnet.
So you put a magnet here. You say that the north pointing towards north, is it correct?
No.
Why?
Because now we have the repulsion force.
Exactly, that's very correct. So actually what happens is this, our Earth, it was designed in such a way that the metals are arranged in this manner, tilted, alright, which is pretty amazing, that this is actually the south and this is actually the north. So when you actually have your magnet, your bar magnet, and it's actually this tight, right? What actually happened is that they are pointing towards the magnetic south of the planet, and the magnetic south happened to be at the north pole. So it's very confusing, right?
Cool. Then they should, oh yeah, they should call the North Pole South Pole or magnetic South Pole. North Pole. North Pole, then it's easier. Then when you see, when it goes to north, then
Is that why they say true north?
Yes, correct. So in the end, there are three north. There are three north. So one is North Pole. Another one is the true north or geographical north. The one that you see in the map, that one is pointing towards about 1 or 2 degrees. And further back here, this is the magnetic north.
So why remain north?
So if you rely purely on compass, typically you want to go to a North Pole, you will not reach North Pole. Rather, you will go, maybe you'll reach somewhere at Greenland. Yeah, a bit tilted.
at least we are not. It's not as cold there.
It's quite cool.
Yeah, but still better than being right on the North Pole.
Okay.
Pole.
Okay. So that is why we have 3 different types of north. Alright? The magnetic north, by using compass, will be a little bit tilted to this side. So the North Pole, geographical north, the true north, the magnetic north are all different.
So the compass will point to the geography.
This one, which is the magnetic south. But we don't want to say magnetic south because people will be very confused, especially laymen. They never learn all this. It's like
Oh, okay, so no wonder because it points there.
yeah, points there. It's still to this side.
Oh.
And because of that, our Earth spinning is also not exactly at the North Pole, so tilted at certain angles.
Oh, so means the North Pole is that way.
Yeah, North Pole is here. Then geographical north here.
It's
It's here.
like that, right? So is North Pole here or here? Does anybody have a magnet?
Yeah, anyone has a compass?
I don't have a compass.
Yeah, so David, does your phone have a magnetic sensor?
I have compass.
No, I don't have.
How does the phone?
Okay, so this is just something extra, so it's not part
How
of the
does the
thing.
phone predict the compass? Yeah, how does the phone predict? Because the compass in the phone.
It's not predict.
They actually use the GPS.
So
where's the north?
It's pointing at my body.
Eaton is the north.
Okay, the north is this point.
Where?
We walk on, you hit the for long if you walk on straight for long time, you hit the
until the
Oh, so the north is there at the back, huh?
Let's head off.
Okay, I want to go south now.
Okay, ah? Okay, this one around.
Yeah, my father also have this compass. The tree.
Let's go to the magnetic
Moving tree.
No.
You already finished, William?
That one I haven't got yet.
Why?
I don't know why it's a tree.
Okay, I haven't got
Geographical north. Uncle David, what's the
North Pole.
Uncle David,
Yeah?
the North Pole, North Pole was that way.
That's it, huh? Okay.
North and
This is geographical north.
This is north.
This is
And
magnetic
geographical north plus this is geographical north. This is north pole. This is the north pole. This is going to be the north.
Okay. Drawing done?
No.
It's going done. Yes,
I'm
I'm
writing
writing
it.
it.
Get a zero.
Oh.
Zero slash, yeah.
Oh, okay.
I'll get 1 degree a zero, 2 degree a zero.
Just write Q.
Gilna. I didn't even want to write you. Bit more, zero, bit more.
It's
I get
too much.
1 degree each, right?
Actually it's a few degrees.
For 2 degree.
Yeah.
So move to 10, move to 10, move to 10. Yeah, the drawing is finished, right?
Yeah, let's go there. After today, everybody will buy a compass.
So then like that,
Okay.
hit the wall, poof.
Induced magnetism. So basically what is induced magnetism is that a temporary magnetic force, alright, due to the presence of a magnet. So for example, induced magnetism, they can act at a distance or by touching. I'll give an example. Let's say that there is a magnet here, and this is north and this is south. And then you bring a piece of iron. What will happen to the iron? You will what again? Okay, attract, yes. It will be attracted. So let's say this is iron. So why is it attracted? It's because this iron has become induced magnetized. Anyone know the word induce means? I'm induced
Less
to eat more. What do you mean?
means less,
Less.
Turn.
like you minus.
Hypnotized.
Hypnotized. You will become. You will change. So to become induced magnetized here, so if this is south, in order to be attracted, this part will become a north.
Oh.
It's temporary. The moment you remove this magnet, this what happens to this iron, you'll turn back, you loses all its magnetism.
Wow.
That is why it is attracted.
So then if you flip the magnet around,
Yes, very
flip the
good.
magnet around, then you immediately become a south.
Correct.
That means we also can attract more ions.
Yeah. And the fact that because this iron becomes induced magnetized, what happens if you put a pin here?
You'll be attracted.
You also be attracted.
Yeah.
So that means that this one will become south, this one will become the north.
Oh my god.
But then if you turn the pin around, then it will become.
See those like you connect a lot of things and after that you find out.
Oh yeah.
Yes, correct.
Daisy,
So-
my magnet, my magnet, I have one very strong magnet at home. I attach one coin, and then the coin could attach to another coin, then the coin could attach to another coin.
Correct, because induced
And
magnetized.
so on. Then
So let's say that you have another pin here, and then another pin here, and then you have another pin here.
depending how strong, after a while the last pin will fall off.
This becomes south, north, south, north, south, north.
But then after a while, it will be weaker and weaker and weaker until finally one will come out. The last one will fall
Yes,
off.
correct. So this north, south,
Shooting nail.
north, south, north, south.
Then if you
Alright.
set attraction too high,
So
then
it can act at a distance it can actually by touching. So you can actually have an induced magnetism as well. So some people ask, one student ever asked, he said, what happens if I put a wood? Will you still work?
No.
Yeah, you still work.
Yes, yes, yes.
Yes,
It's
you still
strong
work.
enough.
Yes.
If you strong enough, you still work.
Yes, it will still work. Why? Because magnetism can pass through
Non-magnetic.
Oh yeah, non-material.
non-magnetic.
material.
What about around a tree?
Yeah, tree is wood, yes.
But have to be a super strong
thing through my
magnet.
hand.
Yeah. Of course, if you have two magnets, you can play. You can put one magnet on the table and then move the next table at the bottom of your bottom side of the
You know,
table.
my friend tried that before when he was young, my father. I played with that.
So if
Uncle David, you know they use the magnet for magic trick. You know they actually put a coin below the bottle. Then they actually below they hang got already. Then they got this like pretend a ring lah. The normal ring lah. Actually the ring is a magnet right. When they come here right, the ring block lah. There you go.
Very good.
But,
So,
so that means if a coin block the magnet, the other coin will go. How does it do?
yeah, let's just say that what happens if this is a wood, let me just rub this off.
magnetic material.
But copper is not a magnetic material.
Oh, copper.
Yeah, whether it's a wood or copper,
And this is
it will still work.
It's a non-magnetic material.
Yeah, so what happens if this is a north and this is a south and you try to attract this iron, but here there is an iron piece.
Cannot.
Why cannot work?
Because the magnet's magnetism cannot pass through a magnetic.
Yeah, the reason was because it's this. So this is the south, right? And then it will actually
Oh, that's why the magnets when it comes hide over and the other one is just the coin just drop.
So you look at here,
All magic trick use signs.
correct? All magic trick is use signs. Okay?
You know they also like show when it disappear right, they use the kind of like mirror.
So you realize that here, this side is blocked. Okay? So this is what they call magnetic shielding.
Shield. We got a shield.
Okay? So it shield,
If people
alright, any magnetic effects, alright, that's caused by this magnet. So for example, when you go to airplanes, before they take off, before they land, it's often advised that do not use your phone, correct? Because your phone might produce this signal called electromagnetic signal that might interfere with the controls of the cockpit.
You know the phone they have
and then
aeroplane mode. But the aeroplane mode cannot connect to Wi-Fi.
Yeah.
That's why.
Do you, of course, given the nature of humans that is stubborn, when you say don't use, they still use. What actually they do is, in those very good airplanes, those big planes, the cockpits, the wall, there is a
magnetic shielding.
iron
Then
wall.
they should just say those big airplanes just say don't need to turn on airplane mode, just use that because they got magnetic wall.
They wouldn't want to say that because it's still for in case.
Uncle David, but then some place got in-flight Wi-Fi.
Yeah.
Yeah, if those planes that have in-flight Wi-Fi, the cockpit will be shielded. So it means that the wall is actually made up of iron. So basically, whatever signals will be blocked. If you actually go to a hospital, sometimes they say do not use phone. Maybe because that site is a magnetic resonance MRI. So in that room, it's all the same thing. The wall has an iron. So for even though say don't use phone, if whoever stubborn still use phone, right? So whatever signals and the magnetic field, right, all will be, yeah, you will just bounce off. So this is the iron wall.
Iron Hospital created by Iron Man.
So then no signal can
enter.
No signal. So basically, whoever go inside, they cannot receive any. They will not able to receive any phone calls.
Oh, because the signal will be blocked.
Yeah.
Then the Iron Man can say, everyone please stop using your phone. If not your phone can just damage your ear.
Are you done?
Wait, not done yet.
Invisible punch. Then the villain, right, they don't need to do anything. Take out phone. Then call nobody.
Then call other villains on all their phones.
Can I copy the magnetic shielding?
I haven't do that. This is how to do it.
No, throw the magnet into the sea iron, then jump. Very easy.
Done already, Joshua?
No,
Have you drawn it?
another.
Have you copied down the induced magnetism already?
I draw that.
I don't draw.
Awesome.
I'm very bad. He's hard to get.
I hate art.
I don't like that. I love art.
Then you draw one human sculpture.
I'm okay with art.
I'm still so young.
You
You know Justin Bieber? Justin Bieber.
Okay, done? Okay, round off my induced magnetism.
Yes, I'm done. He also knows what's magnetism, but his song was kind of
Wait, so that's all for induced magnetism, right?
Yeah.
Yay! I got more space right now. Electromagnetism.
Yeah, I don't know what's so different between iron and steel.
Iron.
Iron starts with I and
Iron
steel starts
versus
with S.
steel.
What the song is he?
Iron Man.
I think pop star. How come Iron Man cannot be called Steel Man? Steel Man.
Nice, fun copying, guys.
You think any material can reflect off the song? Because you can reflect the sun at the next week.
Steel Man.
You like Iron Man versus Iron Man?
Iron Man and steel. If like that, then how come Iron Man is so good?
Maybe.
That's right.
You have two hard to magnetize there.
Can you feel Iron Man is
Oh yeah.
very weak.
What?
Black.
Iron Man is damage.
No, Iron Man, all you need, Magneto can easily win Iron Man.
Yeah,
Magneto.
just
No,
that's yeah.
Magneto use him as real life Angry Bird.
No, because the Iron Man like, I'm gonna punch you. Yeah, like, send him to an island.
So you're done with your stories?
Of course.
Okay.
Nope.
Jisha,
No.
this one?
No.
Yeah, can.
No.
Actually, I didn't write it down, but then I took a photo, so never mind.
No, I already took too much photos already.
Easily them. What's them?
No, demagnetize.
Oh.
Okay. So
Not okay.
we're going to compare two different materials, iron and steel. So here it says that iron is easily magnetized. What does easily magnetized mean?
It's very easy to turn to a magnet.
Okay, so how do you actually magnetize?
Stroke it. Stroke the magnetic material. Oh man.
So ways to magnetize iron, right? So just now Zachary said the first method is
stroking
stroking.
method.
Electromagnet.
Okay.
Electromagnet.
Alright. So these are the three methods that you can magnetize an iron, or matter of fact, any ferromagnetic materials. Okay, so by stroking, how do you stroke? Okay, during the ancient time, okay, like in the maybe in the British or in the Europeans, they have a name called smith.
Dr. Smith.
Okay, so basically their job, one of them, besides producing weapons, is to actually make a magnet. So what do? Is they stroke it. So they use a permanent magnet, north and south.
Just buy one.
Alright? No, they cannot buy, they have to make. So they start to stroke in this direction.
How
Alright?
do they build a permanent magnet without the help of stroking and everything?
Then this will be the second method later. So they will stroke it. So if this north pole touch the surface first, this part will become north. I repeat, if this is a north, when you stroke it, the very surface that it touches first will become north. Okay? Listen, because this one it will be tested. So sometimes they will use two magnets, north, south here, and they stroke it in this direction so that this one will become south. So they will do this for a few hours, and they do it for weeks.
Why not they just heat it up? Heat it.
Correct. Heating is another way.
Heating you don't need to do much, just put it in a pan.
Oven,
just leave it there.
True.
Oven.
Yeah. So what they do is they make sure that this is a this is a iron,
Pure iron.
and then they determine where is the north. Let's say this is the north. All right, and then they heat it. All right, they produce heat. And this is a super slow method that eventually will turn this iron into
Perfect.
a magnet, north and south.
How long gonna take?
This one literally take weeks and months.
How do you set a very high temperature?
You'll still quite take quite so long. Because actually, next time in A level, we'll be learning that how this heat will distort the spinning of the electrons. Okay, the fastest way
Current.
within minutes is current.
Then shouldn't you just use
Electric
current?
Is it
Those days don't have current.
Oh, because current is very dangerous.
Not really. Current is actually quite safe.
Then why last time you say it's really dangerous?
Last time dangerous? No, I said last time don't have electricity.
No, that no electric.
Okay, so you coil the wire.
Electromagnetic.
Looks like hair.
I thought it was electromagnetic, right? Is it so nice?
Electromagnet. I like the term.
Electromagnet.
Yeah.
Oh, is there a battery?
Yeah, that's a battery. So this is a positive. This is a minus, right?
Wait,
So then, but once you
who's
take
that
out
hair thingy?
It's
once
a
you take out,
wire.
then you no more already, right?
Huh?
Once you take out, then no more.
Take out what?
Take
Take out from the battery lah.
Temporary.
This one take this out.
Yeah.
If it's actually for iron, it will be you loses its magnetism quite easily. But if it's a steel,
It's hard.
right? It's a steel, right? If you take it out, you'll still be a magnet. You'll become a permanent magnet.
Oh no, I never.
No, the thing is an iron bar.
Man.
Not necessarily. This one can be iron, or this one can be a steel.
Oh, yeah.
Because it's steel, then it becomes.
Iron Man.
Yeah, correct. You become a permanent magnet.
Iron Man.
Make it more strong.
Iron Man, what you should do is
So
you
you
just
just
run the current through Iron
Quite
Man's
easily.
suit,
To make the
and then all the magnet will all
make it
metal
stronger,
come to
to add more current, to add more battery.
Yeah, correct. Okay, so now we need to learn if you put an iron or a steel here, you will become a magnet, correct? So just now Disha mentioned the term electromagnet. Right, because you become a magnet due to the electron flow. So let's look at the current. Look at this arrow. The arrow go down, 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 correct?
Thank goodness, how you do.
We're going to use this thing called the Maxwell right hand rule.
My right hand. How do I left hand?
Alright? So do like this. Good.
Good.
Yes. Okay. So this is your fingers. Alright? So look at these fingers. These fingers, this is the flow of the conventional current. Alright? So look at this one. Got that right? And Then where's do you see your thumb? Your thumb is pointing to the north. So that means this has become a magnet. So this has become a north pole.
Wow, yeah.
Then looks again.
Look at the current. Can you see? Like that. Can you see my thumb? I mean this part, this section is a north pole.
Oh.
Then this side is a south.
What if you put the battery, you change it over?
Then you'll switch.
Oh, Uncle David, you should put the thumb upside down. They'll be like that.
Uncle David. No. Then if you turn it over, then you should use this hand already.
No. It's still this hand. Huh?
Uncle David.
Yeah?
If you freeze something again. Whenever we discuss electromagnetic.
Yes, correct. Yes.
Change it over the battery.
This battery change, right?
The plus is here, the minus is
Okay,
here. Then you put like
Jisha.
that, it's still the north.
Okay.
Oh, do that.
Jisha says switch, So let me just draw.
The strong magnet was superconductor, right?
Maxwell's.
It's a superconductor and then the game magnet.
Exactly, right?
Okay, like that, right? Okay, so where's the current flow? Okay, try to listen. So current like that. This current now is flowing upwards, right? Correct, Jisha? Still the same hand, Right, can you see?
Oh.
Can you see this?
Because it's going up, then you come
Yeah, it's going up, right? Then you curl down, right, to the back.
Okay.
So, where's my thumb?
Yeah.
Then this is the north.
Oh, okay. I just like
How do we know what happens if there is this?
There's no way that you can become a south. Because we follow this rule.
Oh.
Maxwell.
So if you are pointing to the south, it's actually the north.
So what's the name?
Huh?
No, that means
Somebody come back stays well.
Oh.
So what I mean is that if our thumb is pointing to the south, then it will like pretend to be the north.
Pretend to be the north. The thumb always pointing to the north if we were to use Maxwell right hand rule.
Oh.
Maxwell's left.
So if we go lost in the forest, we just do this, and then we can just follow the.
But this is a magnet. This is not a compass. Okay, unless you have this device in the jungle, and then you make this into a magnet. You put it out, then you put it floating in the river. Then hopefully the river is not flowing. Then you're able to see where is the direction it flows.
The river is always flowing.
Then maybe you should have a puddle of water, a still water.
Why? They just take a spade, you have them dig a. Why do you need water? Dig a hole, take water from the river.
Because he doesn't know where's the north. So because the thing will float, right? Then hopefully your points to the north pole.
What if the magnet see?
Why can't you just don't use water?
Yeah,
You just hang
that's what I was going to say.
Yeah, hanging is a good one. Huh?
What happens if the magnet floats? I mean sinks.
Then too bad.
Then no more.
It's okay, I need the resurrection hook. Okay,
No. Then you go down and the battery die.
can you understand Maxwell right hand rule?
Makes the makes it very well.
I mean,
Wait, I have a question. Is Maxwell a person? Obviously.
He looks like a person to me.
So that means his name is called Max and he's very well.
Maybe. Okay,
wait, that part is done. But
The thing is Maxwell to use his right hand.
I'm not either her.
okay.
All these things are not done.
So basically, whether it's an iron, whether it's a steel, you can magnetize them. Alright? So you can easily magnetize them for iron. You can easily demagnetize if it's an iron as well. So now let's move on to the ways of how we can demagnetize a magnet.
Heat.
I thought his heat is to make it
Dropping
nice.
it. Dropping it.
Dropping it. Hitting it with a hammer. Okay, can I use this as a hammer? Can I use this as a hammer?
No, for you, you use a head.
Yeah. Exactly, are you copying now? Okay.
Huh?
So you hit it, you drop it, but this is definitely a very slow method. You can also heat but make sure that it's in a east-west direction. So it means that you hang it. Yeah, if not, then you make it stronger actually. Okay, so let's say that this is a north. So east-west. Okay, west is here. Okay.
Heating, the light is too.
But of course, these
Won't the magnet spin towards the magnetic south and magnetic north?
you have to actually, yeah, you have a point. This is definitely not a very good method. Because sometimes you let it hang, it will still point towards. So each time the smith have to make sure that this thing, right?
Or maybe if glue will stick onto it and hit the side.
Yeah, but this is definitely not a method that we use today. We use alternating current.
Go to the wall, east and west side, and then keep it.
Yeah, and then you burn down the road.
Alright? When you use a battery, it is a direct current. If you use a battery, it is a direct current. So this is how it works. So this is a coil. So when you coil this thing in this manner, we call this a coil, right? Coiled wires. But of course in physics we call this a solenoid. And we use alternating current. So this is alternating current symbols.
Oh, I think I've seen this.
Okay, what is alternating current? Okay, this is how
we get from the electricity we get from the wall plug.
for the aircon, yes, it's alternating current.
Also, alternating current is actually very high. So this uses alternating current.
The aircon. Yeah, so alternating current means that the current, let's say the first seconds, the current flow here. It flow like that, and then the next seconds, the current flow this way.
Oh, when you hit the fire, then you move the other way.
And then the next thing, they will flow back in
Oh, it makes
this
the
direction.
north pole.
They keep on changing
Oh,
direction.
so then the
Very good.
so then the little
Like
thing
that,
that
you have to
bounces
do the
off.
same direction, but if you make different directions,
So
you
you
Very
this thing,
good.
so you bounce off this thing and go back, and then go on the other his thing and go back.
Yeah. Okay, so just now Jisha pointed out something very interesting. He said that if you, there's a reason that why this thing keep on changing, because it's to actually what? Demagnetize this thing. So when you pass through this magnet through this hole, alright, what happened is that this current will distort the magnetic arrangement of the magnet. And then you pass through one more time, you lose another chunk of its magnetism, you pass through another time, then you'll lose, and then you do it a few more times, you lose the magnetism completely. So this one,
So
you
then
have
you
to,
push it. What?
not push it, passes through. Yeah, push it.
Good, you push it for a moment. Say you push it here like that, you push it in. When it stop here, and then you start already. If you push put the
No, everyone, Maxwell's right hand rule. That means Maxwell's right hand rules the whole world.
This is so small, the hole is so big. It's okay, you can sit down.
I mean, it stops because the force of your push is not enough.
No, that means
To
Maxwell's
like and then the force.
Okay, I like the word you say, why you have to push it like that in this place. Yeah. So basically, you just need to make sure that, yeah, you just can able to push it through, okay, with the sufficient force to go through it. And then if you do it a few times, you lose its magnetism. Was it okay? Okay, maybe pass the magnet through the solenoid.
What's the solenoid?
Oh, there's the wire.
This one, this curve, this thing,
The cup.
this thing.
Oh, it's called
Yeah, that's the
solenoid.
called solenoid. That's how you demagnetize the magnet.
Is that the fastest method?
This is the
The
fastest.
fastest way to take a picture.
Why is it a few times? Because it depends. If you want to demagnetize a steel magnet, right? A permanent magnet that's made out of steel, then this have to do it a few times. Yeah. But of course, if you have a very strong, very high alternating current, then of course the number of times will be less.
David, that means if you have a very high current, then you better be careful not to get yourself electrocuted.
Yeah, that's also another safety issues that we have to consider as well.
Then become the earth already.
So then after if you pass through it,
Yeah, earth wire
when you
saves
go
the
through
day.
it, if you go through the current the
wire.
yeah, if the put the magnet and go through the wire, won't some of the electricity be in the magnet because it's probably some metal. So then when you touch it again, won't you get a big shock?
No. What happens if we touch the earth
Normally
wire?
these will be insulated wires, no?
Okay, so if so don't use it unless it is not insulated.
Most of the wires that we buy, it is insulated. Unless you go to a special shop, then you tell them that I want a bare wire, they also will sell that as well. But for safety reasons, we often use insulated wires.
Then bare wire like.
Yes, Joshua?
Later, since you say the current goes through the earth wire, what happens if we touch it?
If you touch it, depends on the amount. If
Touch
it's
the
high
earth wire.
enough, it might electrocute you.
So that means if earth wire is little bit useful but also sometimes not that right?
Huh? Again?
Maybe sometimes the earth wire not that good because if you touch it, it just electrocute.
True, but normally, when you see a wire here, it's behind the walls actually, so you can't really see it.
But then how they work, later what happens if they connect the plug, right? They connect. When they accidentally touch it, then they get
Who accidentally touch it?
like they because they need to build the whole place, right?
Who is they?
Like the workers lah.
So, normally the workers, they will know how to protect themselves. No? Very rare that you see them electrocuted. Okay. Anyone has any questions? So these are the ways of magnetizing it, ways of demagnetize. And we can see the difference. Iron, easily magnetized, easily demagnetized. So it makes into electromagnet. There's a reason for that. Because, for example, of course in Singapore you won't see it, but if you notice, if you watch this Toy Story 3 or Toy Story 3, there are these junkyards, the metal junkyards. So what actually happens is that, let's say that they will separate between metals and non-metals. So right on top, normally there has these very big iron plates, and then there is coiled wires. Alright? So then they will switch it on. Then what happens to that? This will become electromagnetic. So all these metal pieces, they will go up.
That's how it's done in real life also.
Yeah, in real life. So then after that, they will shift it to this direction. They'll shift it to here. Then what do?
Then Toy Story
They'll off it off. So when they switch it off, the iron loses magnetism almost immediately. So whatever things is here, all will fall.
Just like the Toy Story, same thing.
That's what one of the uses of electromagnet. Permanent magnet, we have seen it quite a number of things. Like for example, in the refrigerator, the door, we actually have a magnet. Sometimes certain doors, the latch is actually made up of permanent magnet.
Latch?
Yeah, at the back, like for example, the door stopper, sometimes they may be made up of permanent magnet.
Door stopper.
Yeah, my friend, right?
Okay, I would like to discuss one question of your homework. Question number 4 in the section A. I think everybody did it. I think Ethan didn't do. So Ethan, you will
Is this
do.
question?
No, the section.
Section B.
Yeah, section A. Can you all look at the questions?
Wait, I didn't really put the same one.
It's the same reasons. Okay, do you all see this? Okay, these are the answers.
Answer 1, 0. Answer 2, 0. Answer 3.
Question, this part, yeah, we learn practical electricity while you're awake.
How are we going to do static electricity?
Yes, we are. Okay, The reason number one is actually all the wires, right?
Yeah.
Are connected wrongly. So basically, you can give the examples. Some people say what's the difference?
It's only earth wire and neutral.
Yeah.
I
Yeah.
go right. The light wire is under this thing.
Ha.
I told you not to.
The second is no fuse.
Yeah, that's what I say. My father also say no fuse, but it just say the wire. That's why my father say how come
No fuse.
I told you, ma.
No need fuse, man.
Wow. My father told me.
Your mom is not here.
Oh, I knew there was no fuse. My father said no fuse.
No fuse was attached to the live wires.
And then the live wire.
This wire.
Then the last one is live wire under the cable.
The last one is
I can
the cable. Alright. Should be above.
At least he got half.
So if you realize these clips, right? The cable, alright, the clip must be here. Alright? So this cable, right, they're containing these three other wires must be exactly your T6.
I thought it was
So
before.
are we supposed to write it down inside here?
Huh? These are the three reasons.
So are we supposed to write it down here?
Well, I don't know, up to you. I'm just telling you this is the correct answer. So it's up to you. You want to copy it down or don't want?
I don't think I really need, but I just need the
I know already. My
MCQ.
father can tell me.
Yeah, MCQ. A cable should be attached above the clip. I thought it was below. Maybe the MCQ number 8 and 50 and the clip is supposed to be like the. So can we go through that one?
long wire, right?
Look at the clip here. It has to actually, okay, hold
Under the clip. Isn't this under the clip?
or under, yeah, correct. Correct.
So I'm.
So have you all done the-
Yeah.
Have you done the fractions?
Left is it like that?
Yeah, light bulb.
Do you want? I don't think I need to write it down, right? Or maybe just write it down, right? Just write it down.
Okay. Any other questions that you want to ask besides this?
Yeah, I think I can. Not really. Figure it out.
I think one of them. I think I need one.
Yeah.
What's 13 for? I think 13.
Huh? 13 for? 13 answer minus 2.
Why is this? Yeah, I think. Uncle David, what's wrong with number 15 in the MCQ?
Okay, we start from the MCQ. From the beginning. The first page, anyone have any questions? MCQ?
No, all correct.
All correct.
All
I
correct.
think I can figure mine out lah.
All correct except question 13. I don't know. All correct except 15. As 15 you don't know. 15 is quite easy.
What is it? 4, 6,
Is
and
answer is B.
B? 9. How?
Okay, sit down please.
You see, it's connected to live wire. Then you see, it must always connected to live wire. Like you see, A, it must always connected to live wire. It's the same thing like live wire.
Why? It's not C.
Don't know. Why?
So lame.
Thanks.
Alright, Ethan, you still see what question 4 is it?
Four.
Okay, can everyone turn to question 4 please?
Question 4
MCQ. Question 4
It's quite
Is it?
easy.
Huh?
Because if you are not correct, you need to know the answer.
Then the safety shutters, what? There's the clue already.
A.
Safety shutters. So when you
Question
listen
3
to
now.
safety, it must be earth wire. Earth wire make it safety.
Question 3. Okay, it says that an electric motor is connected to the main supply. Then what happened? They say the insulator has become damaged.
What did he? What was his answer?
Mine is D. A squared.
Mine is also D.
Huh? Is it paper 1 or what?
Yes.
MCQ.
Yes, question 3.
Who got wrong?
It's D.
Who got wrong? 3.
Do you know why first?
Why?
Okay, so the thing is when the wire is exposed, so there will be a current, right? So if the user accidentally touch it, then you'll get electric shock.
Why there's different colors? Because last time I did the MCQ myself. Yeah, just left the section.
Oh, because the wire damage. The wire damage, then later you touch it, right? You can just boom.
All the MCQ.
Boom, yeah.
Then after that, yeah,
Okay. It seems like you all, majority of you all seems to know. You all can discuss among yourself what are the questions you got it wrong. Okay, can I speak for a while?
No.
Just sit down, please. Just sit down for a while before you show the newspaper.
I have a question about this. How does
Okay, can I speak first?
Thank you.
Can I speak?
Thank you.
Okay, first and foremost, just want to say that, that you all have done well for your mid-years. Nobody has failed. And also, to think about it, that what we are covering is a secondary school syllabus.
silly?
So, for many people who think that it is crazy for an 8-year-old, 9-year-old, 10-year-old to try to learn what is supposed to be learned a few years down the road. So, without your effort, I don't think we can cover so many topics. So, this is just a little book to encourage you all to continue on. If you all find, you're welcome. If you find that next time when we start,
my favorite color.
and as we learn next time, and you find that the topics getting harder, please let me know so that we can slow down, and then we can try to use another approach to make things more understandable to you all. But besides everyone get the same thing, I actually bought extra 3 gifts.
Yay. Four.
Okay, one is most improved, most consistent, and a team player.
I won't get one.
I think you get most improved award. No. Yes.
Is it okay if I speak, Chester? Okay, if you want to speak, you all raise hand. Okay, I just want to speak a few things. Most improved award is given to this particular person that I observed for the past 6 months. That he struggled in the very beginning. His work is quite haphazard because not knowing what's going on. And then slowly could see that he's able to do better. To the point where sometimes I can see that instead of being taught, he took the tutoring or teaching role to help his fellow friends. That is actually a very, very good improvement. And that person is Jisha.
Yeah, I
knew.
Oh, it's also a J.
Come, Jisha.
Oh, okay. That's
Yay.
thanks.
Okay, the next award that I've been wanting to award this person is the most consistent award. So basically from day one,
I'll share this.
from day one until now, he has been making a lot of effort to do more than what I asked. In the very beginning, I gave a lot of work, and that's my intention. I have no intention of be someone, just to sugarcoat everything and make things easy. Because the fact that we are doing secondary school science is tough means it's tough. So, but this person do more. When I asked him to ask everyone to do just 3 worksheets, he did the 4th. When I say don't do, no homework, he do extra one. And his result has been very consistent. And that's Nathan. Okay. I think to me, the most important award is the last one. What is a team player? Okay, my definition of team players is when you are better in the topics, you help others. You have patience, you are kind, and you do not get frustrated when you teach your fellow friends. And how do you become a team player when you are weak? When you are weak, you are willing to listen. You are willing to learn. And even though your friends show frustration teaching you, you still smile. I don't think this is a quality that everyone has. So team players will always make the learning more enjoyable because he always smiles. He's able to, whether he is good or bad, he's okay. I observe this person and I really appreciate because he can sit with anyone and yet he will concentrate. He does not really talk, but he will encourage others when he knows it, and he will ask when he doesn't know and he's willing to learn.
No, Chester. No, it's not me.
It's Xavier. So this is what I will do. If end of the year we have another round, I will really value the team players. The more team players, the better. So team players award can be rewarded to all of you. It's not just one person. Okay? Correct, right? Because if you are always consistent, then you cannot get most improved, but it doesn't make sense, right? If you already improve so much, then likely you can only eye for most consistent. But team players, everyone can get. Yeah. Not everyone can be team players. It takes someone special to be a team players. You want to be team players? If you think that you are good, then you will help your teammates with a smile. It can be very frustrating, especially when that person really don't understand what's going on. You can become the team players when you are weak, because you are willing to learn and you're willing to ask questions. Even though your friends show frustration, you just smile. I like that. And you show that you want to learn, because when I explained, you're quiet, you're taking down notes. And I really appreciate this team player. Okay, so now we move on. So, I don't think you can share, teacher. This is not chocolate.
Yeah, I like the way it's a bit hard. Maybe it's another big book.
Oh,
But
yeah,
something, it's something that can be shaken. So when I shake, then there's a bit of
You
sound.
have this thing yourself,
no. Josephine help me. Yeah, some, yeah, you can see that it's... You want to take a look what is that?
Never anyhow, red also never mind, because it's anything to safer.
Yeah, it's just safer, that's why.
And anyway, it's too hard to open.
You still can't do it.
You just tear it up. It's easier to tear than cut. Yeah, I ripped my one up. So I don't really want to. Oh yes, here.
Okay, let's go on in this paper, we can move on.
Yeah. What?
No.
Okay, now what is it? What's that? What's this?
Checker.
I got no
You
idea.
know play checkers, don't know how to play, then go internet and find how to play.
Yeah. Cool.
I think I still got the same thing, because I can one can shake one then.
Static electricity.
Yeah, no.
I found out that static electricity is included in this year combined science, and it's only the introduction. So I'll just go through the introduction, and I'll wrap up static electricity.
I still got more.
You're gonna rip up a piece.
Oh, that hurt me. I really want just thanks. Chairs. Oh, it's also. Chess.
My mother know how to play checkers.
I don't know how.
Oh no!
I think I know.
Exactly, you know chess, like chess.
Exactly. I know how to play chess. I'm horrible at chess. I'll just play.
Our principal is here.
Hello!
Hello.
Hello, Uncle Gail.
Jump in now.
Hey, Joshua, you caught me that.
Alright, this is static.
Cannot ask recording.
Fortunately, the present give first, if not, brother
Oh,
given
him I don't have
the present.
Surprise visit, man. You should tell Uncle David first that you're coming, then he will buy something.
Okay.
No, not okay.
Let's take a look on static electricity. Since this topic is really new, so I wouldn't really know how detailed you'll be tested. So I'll only know by the end of the year when I get the paper. Then after that.
Present day.
Okay. So static electricity, there is a charge. So the charge is, it can be positive,
And
it can be negative.
negative.
Alright? So if you, let's say that you have a charge, a ball of charges, then there is a field lines. Same as magnetic field lines, you have electric field lines. So the arrow is pointing away from the positive charges. Then the negative. It is actually pointing towards the negative charges.
Back thing before.
Huh? You want to draw? Then we need to draw where this is a positive and negative very close to each other, and there is an attraction. Please draw Mercury.
Did you draw?
My table so messy.
No. I'm dying. It's so much to do. Today is long con. Today is really I hate.
That's a bit like magnetism.
Yeah, actually.
Uncle David, is this under?
No, these look like
Yeah,
a plus sign and a minus
We are all
sign.
learning about physics.
Yeah, today is physics.
Today's a-
Tomorrow physics too.
Tomorrow?
Tomorrow.
Tomorrow you do your homework.
Maybe, maybe not. Tomorrow let's see Thursday. Maybe, maybe not.
This is point
Thursday
nine.
y'all go swimming, right?
No, Thursday no more. Thursday next week.
Neutral point.
Wait. Oh, it's the same thing as magnet.
Yeah, it is. What happens if you have a parallel plate? Let's say this is a plus.
And this is right now. Okay, wait.
Okay.
Oh, this is gonna take 10,000.
And this is the magnetic field lines. And it looks very similar, right? From the magnetic fields.
Can I take picture because I'm late?
Let's see.
Up to you.
Yay! I'm too tired.
I also want to take a copy photo. But then I'm not looking at pictures. If I print out the pictures, then place it on the book. I'm taking a panorama because it's still on. Then you take Uncle David as well. Maybe I'll show you the
Break down with
picture.
this, okay?
I copied plastic picture because just in case Uncle David is inside.
Uncle David is like the picture.
A bit only.
So you should say
But it's
sorry.
not blur, it's too blur, Panel doesn't work well because it's too blur.
Yeah, panel is always blurred. On my tablet
Do you
also.
remember mine is what? My front is how much?
13 megapixel, but then panel will always be lower.
Penny.
Wait, let me take
Because
some
panel is
pictures.
bigger, right? Mine is which one the camera? Which one is the highest?
Okay.
Wait, no.
It's very sharp, isn't it?
Take picture day.
Samsung is what?
How many pages is this? Quite long. Look, but the board is broken.
14.
Okay.
Okay. How do we charge metals? Okay, there is a single conductor and there is a double conductor.
Auntie, you call my mother.
Alright? Okay? A single conductor basically means that you look at there's a ball here and there is an insulator stand. So this is a metal and this is an insulator stand. A double conductor, which means that you have two, alright? So both are metals. So this is insulator, this is insulator, this is metal, this is metal. Okay, how do you charge a okay.
I'm not so done yet. Can you wait for me?
Yeah, sure.
I'm just gonna wait until you finish.
Yeah, then I take picture.
Because I'm feeling a bit lazy now.
I feel too tired.
After prize giving feels like.
Because I want to use my prize.
Then you get a tired award.
Tired award.
Most lazy award
I think my
awarded to
final.
me.
I think the
Draw
prize will be
newspapers.
extra award.
So the price will be 0.
Oh yeah, it is quite a good.
Yeah.
Zero over 4.
Everyone.
No,
No, until paradise.
your homework is to sleep.
No, your homework
Got
is
10
not to
marks.
do any other subject homework.
So if we never do our school
No, don't do the
homework,
Chinese homework. Chinese homework.
1, 2,
No, all homework including
4,
English.
5, 6, 7, 8,
You all like
9,
Chinese?
10. How come got
We need Chinese. I don't mind it. I don't mind the
But this
lesson.
part at the bottom is
But we don't want to do like continuous watching.
Principal watching a lesson.
I say hi to the
Okay,
people.
so let's take a look on the first step. How do you charge a single conductor is to bring the charge rod near the conductor and this thing will happen. Polarization of charges.
Maybe is a rod a magnet?
It's a charge rod. So it means that positive charge. It's not magnet. We are not doing magnet now. We are doing static electricity.
No. Can I go toilet?
Yeah.
After the magnetic thing,
So
everything is magnetic.
yes, it's very, very similar to magnetic field. Okay,
HS.
what does the polarization means?
Ooh.
What does polarize means? Like sometimes when people say that his view or his statements has polarized the people.
That means bad people.
Divide. Alright? When you say polarizations of charges, you can see that there is a division. You can see that this side, which is further away, is the positive charges and the negative are very close. Why? Why is this polarized this way? Why not the other way? Why not like this is the plus on this side and then the minus at this side when you bring the positive? Why?
Oh, it's a bit like
Because
magnet.
negative actually.
Right? Why magnet?
The minus, the plus will attract to the minus and the minus will attract.
Correct. So basically light
It's just like
charges.
magnet, right?
Like poles and like.
Yeah,
Just
but
like
this time we
magnet.
say light charges repel,
I
then unlike charges
really like it.
attract.
It's like magnet.
Yeah, it is like magnet. And that's why there's a polarizations of charges.
Polarization.
So this is the first step. What is the second step that you need to do?
Polarization. Polarize. Isn't that polarized glasses also?
Polaroid, I mean.
Does not polarized glasses, the sunglasses do anything with it?
Polaroid, you mean?
Too
Polarized.
complicated.
I thought there's similar words in sunglass, certain sunglass.
Or maybe that means they block out. They
Yeah. So
Okay.
is it doing
Is
this?
that a person?
no, nothing.
Because you look like a man face.
Where? Where's the red face?
Where?
That one.
This
Yeah,
one?
now no below. When you haven't drawn the minus plus. It looks like then they got the fee and then got the road and
Yeah, but then got no
the
head. No hands, no hands, no hands.
Okay, so the next step is you
then the
do
hands.
No, that's the elephant.
earthing.
Yeah.
Alright, this is what it's called. So what is earthing?
Earthing is making it go to the ground. You know, like drilling something.
Yeah.
It's familiar.
This is
Like the 3-pin part one.
yes, correct.
Earthling.
So you just use a wire.
Wait, that's earthing.
Earthing.
Oh,
I
was
Okay, so basically you can use your fingers, you can touch it, because our body is a very good conductor of electricity. So what actually happens is that the electrons from the earth, they will actually move through the earth wire, and then what do? They neutralize this part. They neutralize the positive charges.
I'm very
Yeah.
Because when I asked what is the polarization for?
Polarization of charges occurs when you bring the charge rod near the conductor. This is this one, where this means you separate.
So does that mean that the conductor thing will separate into 2 pieces in the middle?
No, the charges will separate. It's not the conductor. Charges can move, the electron can move. Huh?
Actually, it's a circle thing.
What's the circle thing? Oh, this one. It's a conductor. So normally they have a ball conductor, metal, and then they have a stand. Yeah, it's made out of insulator. Maybe it can be rubber, it can be a wood. Yeah. So normally in the lab, maybe Nicholas may have seen this.
I never
We all actually
seen
have
this
a
before.
lab sessions. You were able to see this conductor.
So good, you got lab session.
Lab session.
So you mean Nicholas have those kind of course here and
You go to
lab?
lab.
Wait.
Okay,
That's what kind of things you can create.
are you ready? So when the earth comes, you'll neutralize this part.
Oh. So that means there's only one charge.
Yeah. So then the third step is you remove the earth. Alright. Then the charge rod. And then this is what you get. This conductor now is full of negative charges. That's the first step. The next is how do you charge a double conductor?
What does that mean?
So 2 conductors. How do you charge 2 conductors at the same time?
by GBA.
Set double.
Yeah. So cute.
So you bring the charge conductor.
Wait, this thing is stuck.
Closer.
What is a picking thingy? Pick this thing up.
Okay, these double conductors, they have to touch each other. They have to touch. Alright, so you bring a charge, for example, minus now.
Minus 1.
Then what happens? Again, polarization of charges will occur. So the plus is all here. And then the minus is all here. Was it okay?
Oh, cool. Then the minus will also be here and positive.
Yeah. Why is it like that? Because unlike charges attract, like charges repel.
Uncle David, I think my mistake.
Why is it?
How? It's like
Oh,
Find new one.
maybe you have to use something. Okay, so this is first step. The second step is that you separate the conductors. Alright, and remove the rod. And this is like that.
My battery low is 5.
有包冰啊！我有电话跟我帮
No,
忙拍照。
because no, it's because things how
This is only 2 steps.
Hello, people's kissing.
聚会的时候，你一整需要这个咩？
啊
你没电话吗？用这个电话。我等一下，真的。
Let me take a picture. Hey, everyone, look.
Go face on it lah.
Josh, there you go.
it's tiny.
Okay,
Be quite blurry.
so how do you charge a non-metal? This part okay? Can you understand?
It's to bring the electric man come and do everything for us.
He's from Serbia, so you won't be able to come here.
No, by bringing answer the
Is he still alive?
From Serbia.
Is he still alive?
Yeah, is he still alive?
Yeah, it's good.
Okay, I ask brother persevere and I come with this most.
Yeah, you can
Then
ask him.
he says, where's electric man? Electric man.
Okay, how do we charge the non-metals? So today I will stop until here. Is by friction.
Okay, you know what I'm saying.
So non-metal or no, you just rub.
No, best way to say how to find friction. Just go buy a friction pen.
Yeah, friction pen work on friction as well.
But
But
then can you use a friction pen on metal? They use which is friction.
actually, the friction pen is only on the top. But for this case,
Oh, you mean the eraser thingy?
yeah. You see this wood? You see the wood? Then let's say there's a cloth.
Oh,
Wait, the lesson
they say if
drawings.
the balloon they rub
Yeah,
on your hair, right?
Most drawings.
There's friction.
Yeah.
So it might pop. Sometimes.
No, I thought they
say
say
stick with my blanket.
stick.
I just you have to put it on the carpet or something first.
Okay, so wood and cloth, so you rub against each other.
So then they got charge. Then there will be a charge, is it?
Correct. So because of that, there's a friction.
Or then you can create spark and more.
So when there's friction, there is heat. And when there is a heat, there is a transfer of electrons.
Uncle David,
Yeah.
then like that, won't the cloth tear?
Well,
Satera.
not depends lah, depends. But normally if it's a smooth wood, it should be okay. We experience this friction charging non-metals all the time, because each time when you sleep, your hair rub against your pillow. So when your hair rub against your
You
pillow,
rub too much,
then what happens?
fire.
Okay.
Hey, I'm angled from inside out. Band
Yeah. So let's say that this is Chester. So like you say, can rub.
Girl, not me.
So
Yes, a girl.
so let's say that he sleeps.
No, you need to put the whole face.
Okay.
Forget the nose.
Okay.
The nose.
So when he okay. Okay, so let's say that Chester sleeps in the night and then he had a bad dream, his head he keep on moving. Then what happened? So what happened is that when you rub, there is a transfer of electrons. Imagine that that's his hair now. His hair is actually
Standing straight.
is all electrons, full of electrons, all negatively charged. So light charges, what happened to light charges?
Repel.
Repel. So then this is his hair.
No, since you have a bad dream, right?
Chester.
At least like a bad dream, right?
At least like that it will be easier to cut my hair. At least
This is wrong.
Okay.